Okay, so today's class is on Fourier series. Now, Fourier series is a an important mathematical technique. I can say it is a mathematical technique which is widely used in the diverse field of physics. Okay, so many problem of this physics, basically acoustics problem, optical problem, even electricity and communication system in electronics, where we found the use of this Fourier series, right? Even in quantum mechanics. So Fourier series that basically determines the sine and cosine oscillation which are compounded to obtain a given result. So before we start with the Fourier series, let us consider what is a periodic function. How could you define a periodic function? Now, a function fx is said to be periodic for a constant number t, where this t must be greater than 0, and I can say that if x plus t equal to fx. So if this relation holds good for any arbitrary constant t, then I can say that this function fx is periodic with a period of t. So t is called the period of that periodic function. Now, if fx is periodic, then fx must be equal to x plus t. Again, this must be equal to x plus twice t dot 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 fx plus nt, where n is some integer. So for any integer values of n, if this relation holds good, then this function is also hold the condition of this periodicity. And obviously fx equal to fx minus t, fx minus twice t equal to fx minus nt, where n is again integer, then also this fx is periodic function. Okay. Now, for example of periodic function, I can use fx as sin x. So what is the curve of sin x? This is 0, this is pi by 2, this is pi, this is 3 pi by 2, this is twice pi, and so on. On the left hand side, there is also minus pi by 2, minus pi, minus 3 pi by 2, etc. when the sine function starts from 0, the value of sine function is 0, and at x t equal to pi, x equal to pi by 2, this is the rejection of x, and this is the rejection of fx, where fx is sine x. Okay, so it starts from here, reaches maximum value, then at pi this becomes 0, 3 pi by 2 it is minus 1, and so on. Okay, so again in the left hand side it gives the same result. So this is the sine function. Now if this is a sine function, after a certain period of interval this function repeats itself. So sine function, the maximum value and minimum value of the sine function is plus 1 and minus 1. So I can say that this sine is an example of this periodic function. Now if this sine function is periodic, then for any periodic function, with t as particular period, integral from a specific point to another point fx dx, this is equal to a plus t b plus t fx dx, and this also holds good for a plus nt b plus nt fx dx, where n is some integer. Now what does it mean? This fx dx integration from a to b, this represents area under the curve between 2 point a to b. Let us consider this curve. I choose this point as a and this point as b. So this is the area under curve. Now you shift this area to a certain region of point out for t. So you shift this a point, it appears after t. So a plus t is this point, and this point represents b plus t. But the area under the curve remains the same. So for any arbitrary values of n, where n is integer, the area under this curve remains the same. So these are one condition of a periodic function. Now I come to the part that is basically Fourier theorem. Now what does this theorem say? Any single valued function. Single valued function means for any specific value of a independent variable, the function must have single value. So there is no discontinuity at all. So for a single valued function, single valued periodic function, fx, and this single values periodic function fx in interval minus pi to plus pi. So the total amount of interval is twice pi, right? So between the interval minus pi to plus pi of a periodic single valued function can be represented as the sum of series sine and cosine functions. And what is the form of these effects between minus pi to plus pi? The form of effects between minus pi to plus pi, if you expand this in Fourier series, the form will be fx equal to a0 by 2 plus sum of n equal to 1 to infinity an cos nx plus bn sin nx, right? So fx can be represented as a constant a0 by 2 plus sum of this cosine function and sum of some sine function. In another way, I can say that if you add this sine or cosine function choosing appropriate constant, these are constant, so if you add all this sine and cosine series choosing some appropriate constant, you can get this periodic function. You have heard about the series of sine function, series of cosine function, series of exponential function. You have already read about this function. So Fourier theorem represents ultimately the expansion of a periodic function to a certain discrete number of function, okay, and that are basically the sum of cosine and sine function. How could you evaluate, or what are the values of this a0, an and bn? First of all, the values of a0 this will be 1 upon pi minus pi to plus pi fx dx. The values of an will be 1 upon pi minus pi to plus pi fx cos nx dx, and obviously the values of this bn is 1 by pi minus pi to plus pi fx sin nx dx. I will come later about how could you evaluate these three coefficients assuming this series, right? Now before come to the point of calculation of this coefficient, let us say something about the properties of function depending which the properties of function on which the Fourier series ultimately depends. That a function can be expanded in Fourier series or not, this term is conditioned by a theorem. That conditions are basically called Dirichlet Dirichlet's condition. So what are these conditions says? First of all, let us consider that fx is a function. I choose an arbitrary function fx for Fourier series expansion. Now, this Dirichlet condition says that this function must be well behaved. Okay, a well behaved function represent that the function is also well defined, right? So well defined function is a condition of this Dirichlet for fx to be expanded in Fourier series, right? So function must be, I should say not well behaved, function should be well defined first. Then this function is well defined and this function is bounded between interval, as I say, minus pi to plus pi. So function is well defined and function is bounded is the first condition of this Dirichlet. What are the second condition? The second condition is the function must be continuous or piecewise continuous. Now, what is the condition of a function to be a continuous? You know that fx is continuous when right hand limit of that function at any particular value x tends to a plus, x tends to a minus fx. This is the condition of continuity. And there is a piecewise continuous, means there exists finite number of discontinuity. So let us consider a function of this form. At x equal to some point a, this is the form of the function. Now you can see that at x equal to a, the function have two values. One is here and that is here. So if this function contains two values, this function poses a discontinuity at x equal to a, right? So if this function contains discontinuity, though if this number of discontinuity is finite, then the function can be represented as Fourier series. Okay. Another condition is that along with this, the function must have finite number of maxima or minima points. So the function must have maxima or minima points of finite number. So if this is the second condition of this function, and the third condition is that the function fx that satisfies the condition of PV periodicity. So periodicity means fx plus t equal to fx. So this is the condition of periodicity. So if this three condition is satisfied by a function, then the function can be represented as a Fourier series. So this is called Dirichlet's condition. Now come to the part of Dirichlet's theorem. What is Dirichlet's theorem? Now Dirichlet's theorem tells that if a function fx is well defined, obviously periodic, and bounded in the interval minus pi to plus pi, and I can write this interval as both represent same thing. Okay, and has only finite number of maxima and minima, and finite number of discontinuity and also this finite discontinuity exists in finite number, and obviously for x this function satisfies the condition of periodicity. What is the condition? If x plus twice pi, this equal to fx, as this total amount of interval is twice pi. So if all this condition satisfied, that is function is well defined, function is periodic, function is bounded between these two intervals, and it has only finite number of maxima and minima points, and obviously finite number of discontinuity. At the same time, this function satisfied the condition of periodicity between this interval, that means x plus twice pi equal to fx, then the value this function fx can be expanded in Fourier series which converges as to half fx plus fx minus. So if you choose any two arbitrary point at the left hand side and right hand side of the point of discontinuity, then the value of this function fx must be the average of these two functions, fx plus or fx minus. So this is basically Dirichlet's theorem, right? Now, if the function has point of discontinuity, what should you do? If the function fx has some point of discontinuity, let us consider that a function fx is defined in such a way that it has a form phi x between the interval alpha to x less than c, and obviously this function fx can be bounded between alpha to alpha plus twice pi, this interval. And fx is defined as between this interval alpha x to c, this is phi x, and this obviously psi x between the interval c less than a less than twice pi plus alpha, right? So the fx has this two form. So as you see here, at x equal to c, at x equal to point c, the function fx has both phi x and psi x, but at the left hand side of x equal to c, the function has got a form phi x, and at right hand side of x equal to c, the function has got a form of x equal to psi x. So x equal to c is the point of discontinuity of this function, of this bounded function between the interval these two. So how could you expand the form of this Fourier series? No problem, because the function is periodic, and say the function have this form. This is x equal to a, so psi x, say for example like this, and phi x obviously like this. So this is x equal to c point, x equal to c point. So fx in that case can be expanded in a Fourier series but the derivation of this coefficient depend on both the function phi x and psi x at the point of discontinuity. So the form of this a0 that I can write 1 upon pi integration obviously fx dx, and this integration runs from alpha to alpha plus twice pi. Now as this function fx has two forms phi x and psi x, then you can write this as 1 upon twice pi integration alpha to c if fx means this is obviously right, this is fx dx plus c to alpha plus twice pi fx dx. Now in place of this fx between alpha to c, this fx is replaced by phi x, and between c to twice pi, this fx is replaced by psi x. So the ultimate form of this expansion will be fx a0 equal to 1 by twice pi integration alpha to c phi x dx plus C2 alpha plus twice pi sin x dx. So this is the value of this A0. Now An can be similarly, I can found 1 upon pi integration alpha to c fx dx. So this is phi x cos nx dx plus integration, this will be c2 alpha plus twice pi integration fx, sorry, this is psi x cos nx dx. And the value of this Bn, this will be 1 upon pi integration alpha to c phi x sin nx dx plus integration c 2 alpha plus twice pi psi x sin nx dx, right? So I can find A0 in Bn in terms of this phi x and psi x even at the point of discontinuity x equal to c. So I can write the Fourier series by after getting this coefficients A0, An and Bn, and at the point of discontinuity, so at C, there is a finite jump of this graph. As you can see here, that this function have a finite jump. Let us see here, this function have a finite jump at x equal to c. So this function have a finite jump at x equal to c point. So at x equal to c, as the function has got a finite jump, then here the both left hand limit c minus 0 and the limit of at right hand side fc plus 0, this true limit must be different. So this limit are different. Okay, limit and this limit, these two are different, but they exist. So at such point at x equal to c, the Fourier series, the value of fx according to Dirichlet condition is given by half f c minus 0 plus f c plus 0. So at the point of discontinuity, I can get these things. Now, evaluation of coefficient. So the evaluation of A0, An and Bn, these three coefficients. Now we know that we have a Fourier series between this interval between minus pi to pi. So the total interval is of twice pi, and between this interval fx can be represented as plus Bn sin x. So integrating both sides, by so integrating both sides of this equation, what I get from minus pi to plus pi fx dx equal to, as this is a0 by 2 is constant, so I bring it out. So this will be this nothing dx plus sum over n equal to 1 to infinity an minus pi to plus pi cos nx dx plus sum over n equal to 1 to infinity bn minus pi to plus pi sin nx dx, right? So the integration of this cos nx, if n equal to 0, what is, so I get the integration minus pi to plus pi cos nx minus pi to plus pi sin nx. So let us see what happens when I integrate minus pi to plus pi cos nx dx. This will give me sin nx by n minus pi to plus pi, but the value of this sin nx, this will be 0. But if n equal to 0, then minus pi to plus pi cos nx dx, this will be twice pi. So for n equal to 0, from this integration I can get twice pi, but if n greater than 0, I get from integral minus pi to plus pi cos nx dx as 0. Now the same thing happens for integration sin nx dx. So minus pi to plus pi sin nx dx, what I get, this cos nx by n minus pi to plus pi. Now if you put minus pi, so depending on this value of n, either this becomes minus 1 or plus 1, because the cos n pi, this will be minus 1 to the power n, right? So the value of this is minus 1 to the power n, so this will be minus 1 to the power n minus 1 to the power n divided by n. So for any values of n, both things are same, so this will give me ultimately 0. Okay, so and as this cos function is even function, so cos minus n pi, I can write this as cos n pi. Okay, so for n greater than 0, also this integration sin n pi, this will gives me 0. So from the previous page, the value of integration minus pi to plus pi fx dx, this will be a0 by 2 integration a0 by 2 sorry pi, this is a0 by 2 minus pi to plus pi dx. So this will be a0 by 2 into twice pi, so a0 times pi. So in reverse, I can find out the value of a0, which is this. Okay, now evaluation of an. Multiply Fourier series in both sides by cos mx in both sides. So what I get? Fx cos mx equals to a0 by 2 cos mx plus an cos mx cos nx in plus into cos mx plus bn sin nx cos nx. Now integrate. Okay, of this function. So integration from minus pi to plus pi dx, integration from minus pi to plus pi dx, integration minus pi to plus pi dx, and integration minus pi to plus pi dx. So if m greater than equal to 0, this function gives me 0, as I found earlier. And this sin nx into cos mx, what does it mean? Expand sin m plus nx plus sin m minus nx. So what is the value of this? This should be sin mx cos nx plus, this will be n, and this will be m, this will be n, this will be m. So the first term n, second term m, then cos nx sin nx. Second term will be same, only minus sign will be there. So nx cos mx minus cos nx sin mx. This will cancel out each other. So this will be 2 sin nx cos nx. So the value of sin nx cos nx will be half of this. Okay. So as this is a sine function, m plus n obviously greater than 0, m minus n again greater than 0. So both are the sine function, and I integrate this between the interval minus pi to plus pi. The value of this sin x into cos mx for all values of m and n, this function always gives me 0. So the integration under this curve, this gives me 0. So the value of this an will be so integration minus pi to plus pi fx cos mx dx. This gives me an integration minus pi to plus pi cos mx into dx. Right? Now what is the value of cos mx times cos nx? So cos mx cos nx, the value of these things gives me an, there exist three values of this cos mx. This gives me 0 if n not equal to m. This have the form twice pi if n equal to m equal to 0, and this gives me pi if n equal to m but they are greater than 0. This is a special case, and I choose n 1, 2, 3 up to infinity, also n up to infinity as in the previous sum. So m and n are not equal to 0, so only this condition holds good. So this is the right condition. So the value of this will be an times pi. So an will be 1 upon pi integration minus pi to plus pi fx cos, right, nx into dx, because m equal to n here. So again I can say that the value of this term will be equal to an pi delta mn. This is Dirac delta function. So when m equal to n, this gives me pi or 1, or when m not equal to n but greater than 0, this gives me 0, right? Okay, so an except obviously Dirac delta function except m equal to n equal to 0, this point. So the value of an is this. Now I have to calculate the form of this Bn. Now multiply both sides by sin mx. So I get fx sin mx equal to a0 by 2 sin mx plus sum over n equal to 1 to infinity an cos nx sin mx plus sum over n equal to 1 to infinity bn sin nx sin mx. Now integrate. So integration between bound interval minus pi to plus pi dx minus pi to plus pi dx, this again minus pi to plus pi dx, this again minus pi to plus pi dx, right? So as this is a cross term, cos nx sin mx, this gives me automatically 0. The value of sin mx into dx, this will also gives me 0. And what is the value of these things? The second part, sin mx sin nx into dx. Now this gives me minus pi to plus pi fx sin mx dx. This will gives me bn. I choose the sum, remove the sum. So for any particular value I can get Bn as minus pi to plus pi sine nx sine mx dx. So this gives me Bn, and this cross term has again different form. This is 0 if n equal to m equal to 0. This gives me again 0 if n not equal to m, but this gives me pi if n equal to m. So this is a perfect delta function, and this gives me Bm times pi delta mm, except n equal to n equal to 0. Right? So this is a delta function. So Bn into pi into delta mn except m equal to n equal to 0. So the value of this Bn, I can write it as 1 upon pi minus pi to plus pi fx sine nx into dx. So this is the form of Bn. This is the form of An, and I get the form of A0 in here. This is the form of A0. So I found all the coefficient A0, An and Bn, An and Bn. After getting these three coefficients, I can expand a function in Fourier series. Okay, so let us start with an example. Choose a function fx equal to x squared, and this function is bounded between interval minus pi to plus pi. So you can calculate or expand this function in Fourier series. So according to Fourier theorem, I can write the value of A0 integral minus pi to plus pi fx dx. So this will be minus pi to plus pi x square into dx, right? Sorry, there is 1 upon pi. So this will be 1 upon pi cube by 3 plus pi cube by 3. This will be 2x square by 3, x square by 3. So this will be pi cube minus of pi cube. So this will be plus pi. So 2 pi square by 3. So A0 2 pi square by 3. Now come to the part An. So An is 1 upon pi integration minus pi to plus pi fx cos nx into dx. So I apply integration by parts here. And use the formula ILET. So what is the value of this? How could you expand this function? So this will be 1 upon pi. Keep x square as a first function. Okay, so keep x square as it is and integrate the trigonometric function, second function. So this will be sine nx by n, and this integration is a definite integration. So this integration runs from minus pi to plus pi, again minus differentiation of this term. So this will give me 2x square, so I bring 2 outside, 2 divided by pi, again integration of this term and second time integration, so minus pi to plus pi x sine nx by n into dx, right? So this gives me, if you put pi here for any values of n, this sine term give me 0. So if you put minus pi plus pi for both left hand side limit and right hand, so for both the point of this definite integral, value of this function is 0, and this will be 2 by n pi. Again integrate this part x sine nx by parts. You will get x cos nx by n as this cos nx. So sine integration cos nx, negative sign here, so these two negative cancel out each other, and minus two by pi n square integration minus pi to plus pi, so differentiation of x square, so this will be cos nx dx, right? So here we found that if you put some sorry, here one term x remains here, so I integrate this term, so x remains as it is, so x cos nx sine nx no x square come here, so this is cos nx, again 2 by this n square into pi comes here, no x here, huh? Okay, so this x will be differentiated and this gives me 1, right? So 2n square pi, ultimately cos nx minus pi to plus pi minus 2 by pi n square, this is sin nx by n minus pi to plus pi, so this term will give me 0 as put minus pi and plus pi here. So the value of this term, if you put minus pi, this will give me minus 1 to the power n, plus pi. If you put minus pi, this will give me minus of minus 1 to the power n. So 2 by n square pi one term x remains here, x, sorry, this will be x cos nx. This term is 0. Okay, so the term comes here and integrate, oh sorry, this is x cos nx. So if you put this value of this cos nx minus 1 to the power n minus n pi, again minus 1 to the power n, but so this will be pi minus 1 to the power n minus of minus pi minus 1 to the power n. So 4 by n square into pi into minus 1 to the power n here, and some pi's here, so this will cancel out each other, 4 by n square minus 1, right? So some problem is going here, so this is x cos nx. Now put some values of this thing and it will get 4 by n square. So I can write that, so what is the value of this bn? So bn will be 1 upon pi minus pi to plus pi x square sine nx into dx. If you integrate these things by parts in the similar way as I show here, you will get the value of this bn becomes 0. So if x equal to x square, this can be represented as 2 pi square by 3 plus sum over n equal to 1 to infinity 4 by n square minus 1 to the power n cos x, right? So this is the form of this x square. Now it's a special case, so x square gives me ultimately 2 pi square by 3 1 to infinity minus 1 to the power n cos nx. Now put the value of this x equal to pi. So what you get from left hand side, you get pi square, this is pi square by 3 plus sum over n equal to 1 to infinity 4 by n square minus 1 to the power n cos n pi, right? Now if you expand this term, what we will get? Cos n pi means minus 1 to the power n. So this gives me 2 pi square by 3 plus sum over n equal to 1 to infinity 4 by n square minus 1 to the power twice n. Now for any values of this n, twice n always is even. Okay, so as this is even, this gives me 2 pi square by 3 sum over n equal to 1 to infinity 4 upon n square. So now bring this 2 pi square by 3 at the left hand side. What you will get? This gives me pi square by 3. This will be sorry, a0 by 2 remains here. So this will be pi square by 3. Sorry, on the right hand side, this will be pi square by 3 as a0 by 2 here. I get the value of a0 to pi square. So a0 by 2 is pi square by 3, right? So this will be, sorry, not 2 pi square by 3, this is pi square by 3 here. Sorry, this will be 2 pi square by 3. So 2 pi square by 3 at the left hand side, sum over n equal to 1 to infinity 4 by n square. From this part, I will get that n equal to 1 to infinity 1 by n square as pi square by 6. The sum of this series is pi square by 6. So up to this I keep here. I will come to the same thing in my second class. Thank you.